'Cause I'm the data guy, making bytes fly high, diving deep into the data, reaching for the sky, from ETLs to data lakes and pipelines that don't break. Tune in, hang on, and let's make data great. Hey y'all, Data Guy here, and today I got a video for you not on data quality checks, but on data integrity checks. So if you don't know what data integrity is, it's basically like data quality taken to the next level. Instead of just saying, hey, let's make sure this has the right amount of rows and the right amount of columns, data integrity means that that data has to be complete. There's no null values. It's accurate. So there's no, fake values, no duplicates, consistent, and it's also in context for the information that it's trying to create. So you don't have a data set that's around elephants when you're trying to get data around tigers. And so what I'm going to show you today is kind of an extension. You'll see similar data as I've used in my data quality check videos, but instead checking for data integrity. So implementing some checks that are a little bit more complex and deep around, hey, let's make sure this data is not only just has, the right amount of rows, but let's make sure that it fits my historical standards. Let's make sure this data looks right instead of just kind of checking the shape of it. So without further ado, let's get into VS Code and let's start building this pipeline. So the first thing we're going to do, as we always do, is import our operators. And they are kind of a doozy in this situation. You'll need to have the hashlib, JSON. These are so we can process JSON and hash data. Airflow, your DAG. Airflow exceptions, we can throw errors. Your task decorator, so we can define tasks using the Taskflow API. A Airflow variables, so that we can use Airflow variables to store data programmatically. And then the base or chain operator, so you can just chain tasks together. It makes it easier to actually define your operators, or at least the flow of your operators. Sorry. Then we have the dummy operator. We have datetime, S3 hook, local file system S3 operator, so that we can just upload files easily into S3, and we'll use that as a staging area before we bring that data into our actual database. Then we're going to transfer from S3 to a Redshift database. We're also going to use Postgres and the SQL check operator for some of our data quality check or data integrity checks. And then a task group, just so we can group our checks in a single grouping, just visually, and it also helps us make sure that we're running all those tasks in parallel, because that's one of the big advantages of Airflow is that you can run this data integrity check many times in parallel across all your data, or just for slight variations in variables. And so that is why we're going to use the task group here. Well, not really why, but just one of the reasons why a task group is useful here, just for grouping everything within a DAG. And then what we'll also do is, if you've seen my data quality check videos, we're going to use that good old forest fire CSV, which is just in our data folder locally. So here we have forest fire. So nothing really complex there. Sample data, yeah, right here. So you can see it here. And then we'll do, after we've gotten our variable names defined, instead of starting to define our tasks like I have done recently, we're just going to start with a DAG declaration and declare it all within the bounds of that. So here we have just call it simple Redshift since we're using Redshift. Rename this to data integrity check. Sample Airflow, DAG, load data from CSVs, S3, then Redshift, while we're integrating data integrity and data quality checks, because you can't have data integrity without data quality. It's kind of like that square and rectangle situation. And then you have template search paths. This is just a template we're going to use for when we're uploading data into Redshift, so it knows this template of that data to follow. And then we're all set. We have our DAG declared, and we can start uploading our data from our local file system into S3. So this is the part where you would probably replace it in practice, because I can't imagine many of you are uploading files from your local file system in production. If so, let's rethink that design pattern. And so here we just have a simple upload file operation, which is just taking our local CSVs, which are paths, which we defined here, and then just uploading them into an S3 bucket, which we're defining via a variable we're pulling from the Airflow connection store. So you'll need to define an S3 bucket within the Airflow connection store, and that's really all you have here. So after we've done that, we will then create a task that is going to use that hashlib to actually check that the hash of this file. And so this is actually kind of a little tricky. I had to do some research to figure out how to do this myself. But this is a task where we're going to validate that the file that we just uploaded, it's etag, which is kind of, it's just an object that is represents data. So we'll take that object, which has a unique identifier, and then compare it to the local MD5 hash, which has been generated from our historical data. Now, that local MD5 hash will be the same for any data that's, let's say, if you have a data set that's 1.2 gigabytes, it'll always produce the same MD5 hash, as long as it has the same data types. It has the same, like frog would generate the same MD5 hash. If you said frog anywhere, it's always going to generate the same hash. And so, kind of like crypto style, where your secret key, which is your data, generates this MD5 hash, which will always be the same. And the reason why that's important here is we're going to compare a historical MD5 hash against the MD5 hash of this E tag. So to make sure that this data that we're uploading now is of that same size and shape of historical data, because we expect that data to be the same. Let's say it's a daily upload where I'm just ingesting all the IoT data from a factory. That IoT data is going to be the same every day. I expect it to be, so making sure in here that it actually is. So the way we're doing this is just by creating S3 hook, getting our AWS config variables. So again, you'll just create an AWS connection within the Airflow UI, and this is how you leverage those. Then we're going to S3 get key, so get a key from our AWS configs variable. Then we are going to take that object and get its E tag. So that is this object.etag.strip. So this is a S3 method that will take the E tag of the data that's stored within S3. Then, and this is just noting that if you wanted to force this to fail, you could change the CSV file path to the corrupt CSV file path, and that just will show you corrupted data and show you what happens when it doesn't match that hash. And here, what you have is a file hash, where we're opening that CSV file path, reading its file hash, or MD5 hash, and then encoding it from UTF-8, hex digest, and making sure that it is equal to the file hash. So if it's not equal to it, then we'll throw this exception because we're just having this, we're generating the file hash and then just comparing it to the historical one, or to the past one. So here, to our local file. And then here, if it doesn't match the hash of the local file, we'll throw an error message. And that's why we have that raise airflow exception to just trigger the cause the DAG to fail. If the hashes don't match. Sorry, I'm getting all gummed up saying hash so many times. And so then we'll validate the file, validate E tag, just initializing that task. And then what we'll do is create a force file table to just store our data in as kind of a staging table. So this is just a basic Postgres Redshift table. Nothing really complex about that. Just simulating uploading this into a database. And then we also have where I'm going to load it from our S3 to our Redshift operator. And again, using those Airflow variables, backend variables. So when you're creating your DAG, go into the Airflow UI, create a variable that has your S3 bucket, prefix, everything, all the variables you need for this DAG. So you can just reference them like this, and that way you don't have to hard code and change everything. Or obviously you can just redo this whole DAG yourself, but I have the code in the description as usual. Then what we'll do is verify again that the data was copied from S3 to Redshift properly. Sorry, I would make sure I said that order correctly. I didn't just have a stroke. So here we have task ID, connection ID, just Redshift, and then we're taking a SQL command, which is validate Redshift load SQL. So here, what we're doing is running this SQL command. So here we are going to find, and so basically what this SQL check is doing is just making sure that there were no errors that occurred on the update or on the load of this file into Redshift. So this is just selecting any cases from that STL load error, so it's just a database that contains any load errors that reference the file name that we just uploaded, and the limit is equal to 1. So if there's one error, then it's going to cause a error within the DAG and stop the upload or stop validating. So here, just validating that using a SQL check operator. So again, one of the really big advantages of the SQL check operator is you can pretty much do any kind of SQL check you want in there. Just really flexible. Obviously, you don't have to write the SQL file, but it's not super hard. And then finally, what we'll do is we will run a data quality check on the actual rows within Redshift and making sure they match our corresponding CSV file or JSON file. So that initial forest fire file that we took and brought into a CSV and then uploaded. So here we have upload include directory. So using our forest fire validation JSON. So include validation. And then here you just have all the initial values from our forest fire check or from our forest fire data. So making sure that, hey, for all of these values within our Redshift table, let's make sure that they are all equal to the values from that initial JSON read. And so this is, you can kind of think this is like the last step in your data pipeline where, hey, I've gotten all done. Now I want to make sure that everything was uploaded correctly, go row by row. And this is where you're basically going, iterating through that JSON for ID and values, and just saying, hey, does this corresponding value exist in the same place within our SQL database? So if we go over to the row quality check for Redshift Forest Fire, so again, this is just checking, make sure, hey, everything exists. So select Y when, instead of years, we're converting the JSON values into the values that we're using for the variables within SQL. So just enabling that connection there so we can compare the two. And then what we'll do is, now we've got all our data quality checks done. We've got everything uploaded. We are then just going to drop the Redshift table. So this is, a testing framework. So I don't want to drive up my company's AWS bills. So we're just going to drop the Redshift table after we're done. I won't even bother showing the SQL statement because it's just drop table, just to save on storage costs. And then the final thing we'll do is just use the good old chain operator to chain these all together sequentially. Since we've already defined the task group, that'll take care of bringing those operators into their own specified task group. And you're off the races. So now let's head over to the Airflow UI and we'll take a look at what this actually looks like in practice. So let's switch over here. So in the Airflow UI, we can go over to our handy dandy graph view integrated now with our, not task duration, with our, grid view. Combination, the best of both worlds. Actually, this takes me directly to the graph view where you can see it's very simple. Our row quality checks, so that's just because we got a task group to do those row quality checks parallel. We also have our load to Redshift here, just different colors, different tasks. Very simple flow, but a really powerful flow where you're just constantly checking the data, making sure that both the shape of the data and the actual contents of it meet your historical standards. And so cool content, cool stuff to integrate. If you have really high need for data quality or data integrity, maybe you're a financial institution or something like that, or you just need to comply with GDPR. Check this out. Check out data integrity and let me know what you think. So as always, if you like this video, like and subscribe if you want to see more. If you have any ideas for videos, drop them in the comments below. I really do make a lot of videos off of people's comments. So without further ado, have a good one. Data Guy out.